Hey, it's Nick. We're going to do a demo of the Disk Management Console. Now, Disk Management lives in Server Manager, and we'll get to that in just a moment, but I want to make sure we understand something right quick. This is not going to be a walkthrough of your lab. This video will go into much more detail than your lab has you doing. If you want to follow along on your own home virtual machine, you may do that. I encourage it. If you have not watched the setup for this lab for your home VMs, stop this video and watch the setup to get yourself ready for that. I'll be waiting for you when you get back. Now, moving on to disk management. Once again, lives in Server Manager. Now, Server Manager did not pop up whenever you opened or whenever you logged into Windows Server. This button down here is your friend. He will get you into Server Manager. Now, we have all these nodes in Server Manager. Storage node is where disk management lives. We open the storage node, and disk management console is living right there. Now, I have added a ton of hard disks to the server, and disk management has detected that there's at least one disk that I haven't given a partition style to yet. I have not initialized it with a partition style. And it's warning me about that, and yours will probably do the same thing. It's asking me these brand new disks that I have not seen before. How do we want to organize the data on this? Do we want to use a partition style of MBR, which is master boot record, or the GUID partition table, or GPT for short? The main difference of these two is that the MBR can only handle disks up to 2 terabytes. Beyond 2 terabytes, we're going to have to use a GPT. Also, the Windows 8, Windows Server 2012, those are all also using the GPT partition style. I'm going to leave the MBR selected, and I'm going to press OK. All right, that's going to give it a partition style or a partition table to allow us a format of ways to store data on that particular disk. And it was talking about disk 10. That's way down the list on my drives here. We'll see that in just a moment. Now, the disk management console is laid out this way. In the top section, we have any volumes that live on the system, any volumes that have been created on disks that we have. Now, I want to take this divider line. I'm going to place my mouse over it. It's going to turn into a double-sided arrow. I'm going to click and drag. I can drag that up as far as I want it to see a little bit more of that bottom window. The bottom window there shows all of our disks and anything that has been created on those disks. Now, in this disk setup here, what we're dealing with is we have the disk name in this square. We have what type of disk it is, basic or dynamic. The main difference here is basic disk can only handle a simple partition. And what that means is a simple partition is what we normally think of when we create a volume or a partition on a disk. That's what most disks in Windows end up being. Most disks end up being basic. Okay. Now, if we want to do anything fancy to these disks, like create a volume that spans multiple disks, or create a RAID volume, or something like that, we're going to have to use a dynamic disk. And we will see how that works in just a few minutes. Now, disk 0 is unallocated. So all the space on disk 0 has not been claimed for use by anything. It's a blank disk, unallocated. Now, disk 1 here is where my operating system is living. We have two partitions. We have a system reserve that Windows created when I installed it, and we have my C drive, which is installed in the second partition. That's where the operating system lives. Now, if we look here, system partition, it is set as active, and what that means is that is the boot partition. That is what Windows looks at as a boot for all its boot files. It's a primary partition as well. Most of these are going to be primary partitions that we set. Now, all the rest of these disks down here, disk 2 through 10, are also going to have unallocated space on them. Okay, and I accidentally made disk 10 a 25 gigabyte partition. Didn't mean to. I'm not going to use it anyway. Okay, so we can see the list of all of our disks down there. We have our CD-ROM drive down there. It's chilling. All right. So the first thing I want to do is show you how to create a simple volume. So I'm going to show you how to create a simple volume here. Basic disk can handle this. New simple volume. Welcome screen. Next. Ask me how big the simple volume needs to be. I'm going to create 2 partitions on this disk. Now, Windows creates a partition when you tell it to create a volume. Okay? Because it assumes that if you're going to create a volume, you want the partition to be about the same size. So I'm going to choose 512 on my volume size here. And what's going to happen, it's going to create a partition that's 512 megs in size. And it's going to put a volume on that partition. Next on that, we're going to give it the drive letter of Y. Y. I chose X, didn't I? Didn't mean to do that. Y. Next. And we're going to format this partition with the default Windows file system of NTFS. Next on that, gives me a summary screen. Finish up. And there we have it, a new volume Y. Now this created a partition of 512 megs and a volume inside that partition. And if we look in our My Computer, we will see a brand new drive pop up, new volume Y. We can store data in that partition or in that volume just like we would anything else. I created a new folder, there it is. Now, I have the rest of this space on this disk that's unclaimed or unallocated. I can do the same thing here. I can create another partition if I wanted to, take up the rest of that space. Or I could extend my current volume. If I was buttoned up against the end of that space, needed some more space there, I could extend that volume. Let's look how that works. Okay, I'm going to use disk 0. I want to use the remaining 509 megabytes. And boom, I just extended my volume. Now, what I can't do is shrink that volume back very easily. Maybe I can. See? I can shrink it back by, say, 512. Oh, look at that. Okay, so it works. You can shrink a volume back. Now, I want to make sure I make this very clear to you. After you've stored a ton of data on these disks, it makes it very, very difficult to shrink it back when you have data stored on it. It's not going to be able to shrink back over things you've written. It has to have space to do that. It has to have free space to shrink that. So be careful about that kind of stuff. You can lose data real easy. Okay, let's move on. Let's see what kind of cool stuff we can do with dynamic disks, specifically RAID. Let's have a look at some RAID things we can do, starting with disk 2 down here, my first unallocated disk after my OS. Okay, I'm going to right click this guy, and I want to choose New mirrored volume. We'll go with RAID 1 here. It's a nice, commonly used RAID level. RAID 1, mirrored volume. I'm going to go ahead and press next on that. And since I selected disk 2 for a mirror, it already knows I want to use disk 2. Alright? Now, it wants to know what other disks do you want to put in this RAID array, or the group of disks we're going to use here. Mirroring requires at least 2 disk drives. So I'm going to choose the next guy in line, or disk 3. Press the add button, and I'm going to press the next button on that. And it's going to ask me for a drive letter. I'm going to choose M because it reminds me of the word mirror. And press next. And choosing the NTFS file system with a quick format is perfect for me. Next, a summary, and finish up. And here's our warning. I can't do this with a basic disk. Basic disk can't handle RAID volumes. So if you want to do this, we have to convert these disks to dynamic. Okay. Yes on that. So now it's going to convert to the dynamic. We see right there. Now it's going to start creating our RAID volume, and boom, it's done. Now these two drives are spoken for. They're both participating in this M volume, this RAID mirror. Now we see it up here as well. New volume M mirror, and let's widen some of these columns out here so we can see them. Looks like we're all good on that. Okay. Now, each of those disks was how big? About 1 gig. We can see that indicated right here. 1 gigabyte in size is what this disk is. If we look up here, new volume M, this has 2 disks in it, but the size is only 1021 megs, or about 1 gig. Okay. Now, that's because we are mirroring information from one disk to the other. We can't use both of them to add that storage together. We have to have that safety net going on. So let's look at how it looks in the computer. In my computer screen, we have a new volume M. Now we can change where it says new volume very easily by simply choosing rename. But I actually want to show you where that's kept. Properties is right here. This is the volume label. That's what that's called, a volume label. I'm just going to change that to the word mirror, so I know what it is. I'm going to press enter. You can press OK, whatever you want to do. So if we double click on this M drive, M volume, we can store data just like we store anything else. Test 1. Okay, files, folders, whatever you want to store in that. So let's close that out. Okay, so now we have a mirrored volume in our disk management. This RAID stuff we're doing, I want to take a quick aside and make sure that we understand something. What we are doing is creating RAID volumes inside the Windows operating system. This is called software RAID. Now, whenever you talk about RAID, and you talk about RAID 1 and RAID 5 and all these RAID levels, typically what people are referring to is hardware-based RAID, because that's the more reliable version of RAID. That's the more reliable way to implement it, is through hardware. What I mean by that is, just like you have a video card installed in your computer or a sound card, in a server you would put a RAID card, and your disk drives would be plugged into that RAID card. And whenever you boot that server up, while it's going through its BIOS checks, you're going to see a little key combination to press to enter the RAID BIOS, or the RAID hardware configuration. It is in there where you would actually configure the RAID configuration, the RAID setup, so that by the time that an operating system is installed on it, the operating system can be installed on the volumes created by those RAID arrays. Okay, we don't have the luxury of RAID cards, RAID BIOS in these labs. So we have to recreate this using what we do have. In this case, it's Windows. Windows just so happens to have a way for us to recreate a RAID array using software, using our Windows operating systems, built-in functionality. So I wanted to make sure we understand that this is software RAID. Now it works, but it relies on the operating system to be functioning in order to set it up or in order for it to really do its job. Whereas hardware RAID does not rely on any operating system to work. It just has to have power and that kind of thing. So software RAID is what we're doing here. I typically don't recommend software RAID to production clients. Not near as reliable as hardware RAID. So just keep that in mind. So let's move on and create us a RAID 5 volume, starting here with disk 4. Disk 4, right click on the square there, and we're going to create a new RAID 5 volume. Now it's the same exact process as creating a mirrored volume. I clicked disk 4 to do this, so it knows I want to use disk 4. So I'm just going to go down the list here of next available drives. Disk 5, I'm going to add that one in there, and disk 6. So disk 4, 5, and 6 now is what I'm going to be using for my RAID 5. Now this is at least 3 drives is what RAID 5 requires. You can use more if you so choose. I want to caution you with this RAID 5 as applies to Windows software RAID. In a hardware RAID environment, you can just add more drives to an array, go into the RAID BIOS and select those drives to be added, and it will extend the volumes accordingly. Windows, that functionality is not native to the Windows RAID setup. The number of drives you create in your RAID array in Windows RAID, that's the number of drives you're stuck with. To add more drives to your array, you have to blow it away and recreate it. Okay? There are some tools you can install to add some functionality to that, but natively, Windows can't extend a RAID volume with more drives. I just want to make sure you understand that. So 3 drives is what I'm creating on my RAID array, the minimum. So next on that, and the drive letter, I'm going to choose the R volume because it reminds me of RAID 5. Next on that, we're going to use the NTFS file system with a quick format, summary, and finish on that. Once again, we can't do this with a simple or a basic disk. We have to use dynamic disk to make this happen, so we're going to press yes on that. Converts them to dynamic, starts to create the volumes. We see the volume stripe happening there with the blue bar on top. And we're going to sync up here. In just a moment, we should have our volumes, and we do. Okay, now I want to make sure that we cover this new volume R right up here. So we see it. Now we have 3 drives, each 1 gigabyte in size, 1 gig, 1 gig, and 1 gig. Now we're striping, so you would think 3 gigs of space, that's awesome. But we're also using parity, which takes up some room, the equivalent of the space of one of those disks. So we lose the space of one drive. How big should our volume be? 3 gigs minus 1 gig is 2 gigs. There it is, 1.9, close enough. All right? So we're right on par with what we should have storage-wise in a RAID 5 volume. Let's look at how it appears in our My Computer window. Just like another disk drive. There's the R volume, chilling, doing his thing, and I chose the wrong volume. Hey, good job, Nick. There he is. Volume R. Let's create a new folder, test 1. There we are. Okay, so we can store data, do anything we want to on a RAID 5 volume just like we can on a mirrored set or a mirrored volume. And I meant to actually change the drive label on that, but I'm actually going to do that here instead. Okay, properties. There it is, RAID 5. Enter. So we can change the drive, the volume label, not only from the My Computer window, we can also change the volume label inside the disk management console. So true to Windows format, there's a trillion ways to do the exact same thing. Okay, just keep that in mind. Windows is great about that. There's a million ways to do the same thing. Okay, so now let's make a striped volume. Okay, I covered striping in our discussion on disk management, but I want to show you how a stripe looks. So starting with disk 7 here, I'm going to make a new striped volume. Okay, same process as the other ones. I'm going to use disk 7 and disk 8. There we go. Next, and I'm going to choose the S for striped. Next, keep the NTFS file system. There's a summary. Finish it up, and once again, need dynamic disk to do this with. So yes on that. Converts to dynamic. There's our volumes, and boom, there's our stripe. All right, now let's have a look at our new volume. We have 1 gig apiece on our disks. There's our storage size, 2 gigs. We get the space of both of those drives because we have absolutely no redundancy. This is just 2 writes at the same time. Okay? And about half of the class just heard office space when I said that. I'll leave it right there. Okay, so we've created RAID volumes. So what now? Okay. First of all, I am going to make sure I know some information here, because what I'm going to do now is I'm going to show you what happens when drives fail. What happens to our RAID volumes when drives fail? This is not part of your lab, but feel free to recreate this on your own. So starting with disk 2 and 3, those are my mirrored drives. Okay. Starting with disk 4 through 6, those are my RAID volumes, and I'm keeping this in my head. You can write them down if you're following along on your own VMs, whatever your disks say on those. So what I'm going to do now is power down this server, and I'm going to work with the disks on my VM side, detach some disks to simulate failures. So here we go. So I'm going to fail drive 2, drive 5 from my RAID array, my RAID 5 array, and I'm going to fail drive 8 in my stripe. So we're going to see how each of these arrays responds to a drive failure. So shut down. We'll come back when this is powered back up. or whenever I shut this operating system down, we'll see how to fail some drives, and we'll just choose a reason out of here. I'm click happy today for some reason. We'll choose a reason, doesn't matter what it is. Okay. All right, here we are. Now, we're going to choose the settings of our VM, our server VM here. Go to our storage, and here are all of my disks. And so disk 1 was my simple volumes. That's what I was using for simple volumes. Disk 2 and 3 are my RAID 1, or my mirrored volumes. So I'm going to take disk 2 and detach it. Okay, that leaves disk 3 as my only mirrored drive left. Disk 4 starts my RAID 5 stuff. So I'm going to fill the middle volume, or the middle drive, sorry. There's that interchangeable terminology, right, that I said I'm a culprit of. There it is. So disk 4, 5, and 6 are my RAID 5 disks. So I'm going to take drive or disk 5, and I'm going to detach it. 4, 5, and 6. So 7 and 8 are my striped volumes. So I'm going to take drive 8 and detach it. So I just suffered a catastrophic failure. Someone broke into my server and just started unplugging disk drives. That's what I just did in this VM. This is the equivalent of someone going in and unplugging cords from disk drives. And let's bring up our server again and see what these volumes do when they suffer drive failures. So we're back in Windows here, and we're waiting for Server Manager to pop back up. My wife made this excellent banana poke cake, and this has nothing to do with the lesson at all, but she made an excellent banana pudding poke cake, and if you ever have a chance to make one of these at home, do it. It's fantastic. So now that that's over with, let's get back into this. So Server Manager, storage node, disk management. Let's see what the volumes did when we failed these drives. Okay, we see right off the bat something has happened. Okay, we see some yellow splats. We see mirrored, failed redundancy, RAID 5, failed redundancy, and for some reason our striped volume has just decided, I'm going to stay up. Okay. So let's have a look at our drives in the bottom section here. And it's quite possible that I failed the wrong drive for our stripe. I've been known to do that kind of stuff. And yeah, I did. See our stripe right here? It's living, it's jumping around, doing all kinds of stuff. Who knows what's going on with this? So I guess I failed the wrong drive for our stripe. I'll find that and I'll pull the rug out from under him. So if I scroll on down on my drives, I see one of our RAID 5 disks says missing, and one of our mirror disks says missing. But we can see up here the volume is still there. It just has a yellow splat. It says failed redundancy. Let's have a look at our My Computer window. They are still there. RAID 5, R, mirror, M. I can go in. There's a test 1 folder that I created earlier. I can make a test 2 folder. Alright, I can write to it. Same thing with my RAID 5 volume. Let's make a test 2 in him. Okay, press the button. Let's go. Test 2. So I can write to both of these volumes. Even though I suffered a disk failure in both of these arrays, I can still read from the volumes and write to the volumes. So that's great news, because now I have some redundancy. Even though it is software RAID, and even though it's not near as reliable as hardware RAID, I understand that, but it's better than nothing. That's for sure. So we're seeing how this RAID has reacted to our disk failures. And this is awesome. We can suffer a disk failure and keep on trucking. What we've done here with these RAID volume setups is, assuming someone didn't pop the case on our server and start pulling plugs on drives, right? Assuming that really didn't happen, what most often happens is a disk will just fail. Up until recently, we didn't always have solid state drives. We had the kind of drives that have platters spinning inside of them and actuator arms reading the data like a record player. Those moving parts fail. They just do. Okay? It's never been a matter of if a drive fails. It's always been a matter of when. And so you have to be prepared for this kind of stuff. And RAID is one of the ways we use to be prepared. So we know we're going to lose a drive at some point. We know it's going to happen. RAID helps us be prepared for those drive failures. So now we've simulated 2 drive failures, and we bought ourselves some time after those 2 drives just tanked. We bought ourselves time to replace those 2 drives, keep on trucking. In the meantime, we're waiting for those drives to come in. And when a maintenance window arrives, bring the server back down, install those drives back into the case, and we're back up with full redundancy. Now, let's get something else straight here. We have failed redundancy. What that means is, especially on this mirror set here, I've already lost 1 drive. I have 1 left. That drive can't fail. If that drive fails, that whole volume is toast. I'm not going to get things back. But I hope you have good backups. And the RAID 5 set, well, I have 2 remaining out of the 3. But that parity information needs 2 drives to be active, at least. It needs at least 2 drives to be active to keep that the parity information in check. If I lost another drive, that parity information is not going to be able to rebuild what I had. That whole volume is going to fail. Okay? Even if I had 4 drives in my array and lost 2, I still don't have enough parity information to rebuild those. I would probably have to have at least 5 RAID 5 disks to suffer more than 1 drive failure. Okay? And I'll spare you all the gory details of creating a new RAID 5 volume with more disk drives. You can do that on your own. Now you know the process. We can blow these things away and recreate them all we want to. For instance, this Stripe volume that I totally failed on removing a drive from, I'm just going to go ahead and blow that Stripe volume away. So to do that, here's one of the disks in the Stripe volume. I don't have to have both of them. Just right click it and choose delete volume. And this is going to erase everything you put on there. We understand that. So yes. And now my Stripe volume is gone. Now I can use those disks for something else. Okay? Simple as that. Now, I can power this server down, reattach those hard disks, and move on. Now let's look at how it's done, because some of you may want to create new hard disks for this, and it's not the way it works. Let me show you. So I'm going to shut down one more time. This has to be powered off to do maintenance on these virtual hard disks. Let's choose some kind of a crazy reason out of here. Okay, we're down. And go ahead and press our settings again, back to storage. And with our SATA controllers selected, that is very important. That's where our hard disks live. If I attach these disks to IDE, it wouldn't matter. Nothing can see them. Okay. Make sure we have the controller that has our disk drives on it. Always helps. We're going to press this add a new attachment, add a hard disk. And instead of choosing a create a new hard disk, we're going to choose an existing hard disk. I'm going to look for the ones that I've deleted. So missing lab disk 2. So we'll add that one. And there he is. And lab disk 5 is another one I'm missing. So choose that same process. Choose existing lab disk 5. There he is. All right. That's how we add those disks back. And lab disk 8 is also missing. So I'm going to throw him back in there as well. Lab disk 8. There he is. Okay. And light him up. And we're back up in Server Manager. Here we go. We have now found the problem. We've replaced our hard disks. And let's see what disk management has to say about the whole thing. Now we're probably going to show failed redundancy still on these disks, and it's exactly what I expected. And it also did something screwy with the order of all of our hard disks in here. This is one of the things I don't like about Windows RAID controllers and the way it does this stuff. It gets our disks all out of whack when we unplug and replug disks and things like that. It's just a big mess. So the reason we say failed redundancy still whenever we have these disks plugged back in to our system is because the disks that we unplugged previously, when we plugged them back in, Windows deactivated the disks. So the ones we unplugged, we have to come back in here and choose reactivate disk. And that's going to make the RAID volume recognize, okay, that disk is back now. We can use it. And once it resyncs the information that I wrote previously, when the array was failed, or in a degraded state, I should say, it's going to resync that, and we're going to be good to go. The same thing has to happen to our RAID 5 volume. Our RAID 5 volume. Here's one more thing I don't like about our bit here. The disk number in the RAID 5 sets were 4, 5, and 6. Now 4, 5, and 6 look completely different. So I have to kind of do some guesswork at which one was the one that I unplugged. And I'm going to guess that it's disk number 6, and it's not. So I have to go hunting for the disk that I have. And I guess whenever I reactivated the mirror disk that I plugged back in, it also found the RAID one that I unplugged and fixed it as well. Just one more kind of quirky thing about Windows and the way it does RAID. Now, like I said, this has not been a walkthrough of your lab. We went into a little bit more detail than the lab can go into, mainly for the time that we have to work these labs. But while you're doing these labs in class, feel free to expand and do even more with this stuff. The more you do, the better you're going to get with it, and it's just going to make you that much more comfortable. The more comfortable you are with this stuff, the better you're going to understand it. And that's what it's all about. Not just learning, but understanding. I want to make sure you understand the concepts and not just know them. Okay? As always, if you have any questions on how disk management is put together, what things you can do with them, please shoot me an email. I'll be glad to answer as best I can. So until next time,